Hi everyone, it's Mrs. Summer here. I'm here to talk about lesson 104, what is quantum mechanics? In today's lesson, students will be able to compare and contrast the Bohr model to the quantum model of the atom and explain how quantum mechanics is used in the real world. If you recall from lesson 103, the Bohr model is a simple model that describes that the protons and neutrons are in the nucleus and electrons are in the energy levels that orbit in circles. There are limitations with the Bohr model. It's too simplified. As scientists have discovered more details, they have to build a new model. So as their understanding of the atom becomes greater, their model needs to be more detailed in order to account for those understandings. Brings us to the quantum mechanical model of the atom. It's the most advanced and accurate model of the atom, and it describes with more detail where electrons are possibly located in the electron cloud, and it explains energy levels using quantum numbers. The way the quantum model describes quantum numbers is by using orbitals and energy levels. The energy levels of electrons are labeled by principal quantum numbers n. So if n is 1, it's in the first energy level. First energy level. It means it has the lowest amount of energy. As you increase the number for n, it has more energy. Within each energy level, there's a sublevel. The number of sublevels depends on the principal energy level. So principal energy level 1 has 1 sublevel. Energy level 2 has 2 sublevels. Energy level 3 has 3. Energy level 4 has 4. Each sublevel has a different shape. The shapes are labeled by letters, but the letter does not describe the shape. So what I mean is the s orbital doesn't look like an S. The f orbital doesn't look like an F. They have specific shapes. They just don't look like the letter they are named for. Because the principal energy level 1 only has 1 sublevel, it only has the S sublevel. The second energy level has 2 sublevels, so it has the S and P sublevels. Energy level 3 has the S, P, and D. And energy level 4 has the S, P, D, and F orbitals. When we discuss orbital shapes, we talk about the shape of it and where the electron can be found. So the 1s orbital is a sphere around the nucleus, and it tells you that the electron is in the orbital closest to the nucleus. The s tells you that it's a sphere. The 2s orbital is the same shape as the 1s, except the electron is slightly further out away from the nucleus. So if we have the nucleus here, we'd have the 1s and then the 2s. This is very similar to the Bohr model. Then we get to the p orbitals. At the first energy level, there's only the 1s because the one energy level only has 1 sublevel. So we don't see the p orbitals in the first energy level. The second energy level, it looks like a dumbbell. The p orbitals look like dumbbells, and they are in 3 directions. So if we were talking about an XY axis, we can have the dumbbells. I love my little drawings. And then there's one coming out and going back, so 3-dimensional. And those are the probability or the locations where an electron could be found, the most likely place it would be found. And then the d and f orbitals, the d has 5 directions. If we look over here, and the f has 7 directions. These numbers, 5, 7, 3, 1, each direction has a certain number of electrons it can hold. The s orbitals can hold 2 electrons. The p orbitals can hold at most 6 electrons. The d orbitals, because they have 5 directions, can hold at most 10 electrons. And the f orbitals, let's see, the f orbitals can hold at most 14 electrons because F has 7 directions, so each direction can hold 2 electrons. So 2, 2, 2, 2, 2, 2. So F can hold 14 electrons. 14 electrons, whoops. There are a variety of uses of quantum mechanics in the real world. Many of those technologies you are currently using, like computers, LED screens, lasers, GPS, digital cameras, and many, many more. Watch this video, Quantum Technology in Your Pocket, in order to be able to answer this week's learning assignment and mastery check.